Student, here we discuss about complex ion and how in which region they will fall and what is the correct order of wavelength of the given complex ion. I'm Veena Dikshit. If you like my video, if you like, then subscribe my channel. God bless you. Thank you for watching. So this is complex ion of cobalt with ammonia. This is complex ion of cobalt with cyanide, and this is cyano complex we can say, and this is water complex of copper, and this is water complex of titanium. So titanium with water ligand, copper with water ligand, cobalt with ammonia ligand, and cobalt with 3 negative charge on this. So what will be the, first of all we have to see what is the oxidation state of all of them. So this is having 3 positive, this is having 3 positive, this is having 2 positive, and this is also having 3 positive. So what does it mean? That copper is having lowest oxidation state. All A, B and this D, they are having 3 oxidation state plus 3 oxidation state. Okay, this is plus 3, this is also plus 3, and cobalt in both the cases it is plus 3, and copper is in plus 2 oxidation state. So lower will be the oxidation state, higher will be the this wavelength. Okay, because and weak field ligand, we have to see only 2 things: weak field ligand as well as oxidation state of central atom. So cobalt, we will see here, cobalt is having NH3 ligand which is moderately strong, CN is having a strong ligand field, and water is having least electron field. This strong CFSE, crystal field splitting energy. So we will see that water is present in this complex and this complex, and water is a weak field ligand. Okay, so but here oxidation state of copper is lower than the titanium, so it will having maximum, see, plus 2 oxidation state and weak field ligand both favor that it should have more powerful longer wavelength as compared to rest of other. Cobalt is a strong field ligand, so it will having least this wavelength. Okay, here see lambda 310 and nanometer, cobalt with NH3 complex 475 nanometer. It fall in visible region, and cobalt is in UV region. So sometimes they can ask this type of question also. This is in UV region and this is in visible region. Okay, now I told you stronger ligand create a longer splitting energy and requiring high energy light. High energy light means shorter wavelength. Okay, so this is having shorter wavelength for DD transition, whereas weaker field ligand small splitting energy and delta O, that is resulting in lower energy absorption, so longer wavelength. So here we will see these two are having longer wavelength and this is having longest wavelength. How? See here, I have written in this way that it is having 310 nanometer, this having cobalt with ammonia complex 475 nm approximately, and this is 498 titanium complex, and copper complex is having 600 nm wavelength. Maximum wavelength is absorbed by copper. So here again I have written, see, titanium and water I have compared. Here is strong absorbed wavelength, shorter 498 as compared to these two. Okay, and longer, this is 600 nm. But when we are comparing with cobalt and this cobalt both complex, cyano complex and ammonia complex, it is a strong field ligand as well as plus 3 oxidation state, so it is having minimum this wavelength as compared to this cobalt ammonia complex. Clear? So here we have taken all these things. Now I want to tell you, if it is CuH2O whole 4 or CuH2 6 times water, at that moment also the same wavelength will be absorbed by this, because we are watching oxidation state of copper. In both the cases oxidation of copper is plus 2, so lower oxidation state as well as weak field ligand, so it will favor high wavelength. Clear to you? So see here, longer wavelength, absorption of longer wavelength done by whom? By copper complex. And this is which is having minimum absorption, this cobalt complex. Thank you for watching. I think everything is clear to you. Energy delta O is inversely related to this wavelength is inversely related to crystal field splitting energy. Means more will be the CFSE, lower will be the wavelength, higher will be the higher if it is higher. Understood? Higher delta O, so lower wavelength. Clear? Inversely related, and vice versa. So stronger ligands create a larger splitting energy, so shorter wavelength. Larger energy, shorter wavelength. Higher energy, longer wavelength. Thank you for watching. All the best. God bless you. Write on each and everything, my child. God bless you, and you get success. Only thing you have to study harder and harder and harder. And don't discourage yourself. You can do it. I am 70 plus year old and I am doing this, so why can't you? Okay? All the best. Thank you for watching. Write down everything, my child. Bless you.